Hello. Hello, good afternoon, everybody.
Good afternoon, ma.
So we are going to wait for like 5 minutes so that others can join. If you know anybody that is meant to be on this call that is not here, please you can feel free to kindly share the link with them. We're expecting over 100 participants and we just have less than 20. So give them some time to join before we start.
What is looking at? That, I think I understand. What I mean is just you guys get some. Yeah, but you are the man. Like I don't, only I don't like give the man laugh. No, no, nothing.
Real side.
Hello? Hello? Can you hear me? You can use the chat. Just indicate in the chat if you're able to hear me. Oh, great. So what about the people on YouTube? Are they able to hear me? I guess they are. So we are going to start right away, and we hope the others are going to join us. Like I put in the chat that the class reps to identify themselves and indicate their departments. Please, you can go ahead to do that. I've just gotten a response from one person. Please kindly identify yourself and your departments. I also want to ask whether all the class reps are in the group chats created for the lecturers and the class rep. If there's any class rep that is not in that group chat, please let me know so that you can be added to the group chats for ease of information dissemination. So I'll go right away. I'll begin right away by sharing my screen. And I want to welcome you to this class, CSC 227, Introduction to Computer Processing. So my name is Mrs. Chika Ojiako. I'm one of the course lecturers for the course. And today we are going to look at an overview, just have an overview of the course, what the course is all about. So I will share my screen and we'll take it from there. Just 57. 57, the number is too small. I don't know. I don't know what can be the problem. Why is it that people are not able to join for this class? Please let me know if you can see my screen. Just a minute. Let me put it in slideshow. Are you able to see my screen? You can let me know in the chat, please. Okay, so you can see my screen. Great. Okay. So like I introduced the course. The course title is formerly CSC 207. The new course code is CSC 227. And the course title is Introduction to Computer Processing. Computer Processing. So in this course, we are going to be looking at what is a computer. We need to understand or remind ourselves about what is a computer. Then we'll talk about the different types of processing modes. We'll start by data. When you say data, what do you understand by data? Then information, then knowledge. Then we'll look at computer hardware and software. Then we'll look at different modes of processing. Then we'll also talk about the internet, computer networks, and basically that's just what a broad overview, what the course is all about. So in today's course or lecture, we are going to look at Introduction to Computer and Information Systems. So at the end of this course, it's expected the learning outcomes that you'll be able to understand what a computer is, what makes up a computer, the inputs, the processing, and the outputs. Then also understand the hardware and the software and the other broad classification of software, where we talk about the system software and the application software. So if at any point you have questions, please just put them in the chat. I purposely muted everybody so that we can have a serene environment. So at the end of the lecture, I will be open to take your questions and also make use of the chat box. So we'll look at what is a computer. Like I already said, the hardware components and the software components. So at the end of today's class, you should have an idea, or you should be able to fully understand this concept. So at one point in time, we have done one computer course, whether in our secondary schools, and for some schools, even in the primary schools, they go as far as teaching them basic things like what is a computer. So a computer can be defined as an electronic device. So it's an electronic device that accepts inputs in the form of data, and it processes the inputs to give out useful information in the form of outputs. So that's a definition of a computer that encompasses the three main components, which are the inputs, the processing, and the outputs. And they can be those components can be classified under the hardware. So the question now is, what is hardware? So when you say hardware, what is it that you're trying to, what does it mean? So a computer hardware is or are physical components that makes up a computer. So the components that you can touch, physical, you can touch them, like the mouse, like your monitor, like the printer, like your scanner, even the laptop itself or the desktop, as the case may be. They're all hardware components, physical, they can be touched. And like I said, you can further divide those physical, those hardware into input devices, which are input devices are things that allow you or allow the computer to take data from the user. And an example of an input device is your scanner. Scanner is an example of an input device. You can also use the chat box to give us some examples. There are many examples of input devices. Scanner is one of them. Your mouse is one of them. The keyboard is one of them. And I can ask you that since we define the computer as a mobile device, as an electronic device, is it right to say that our smartphones are a computer? Can we classify our smartphones as computer? So I'm in the chat to see your response. If you want to talk, you can raise your hand. Yes. So there's keyboard, there's mouse, yeah, there's light pen or stylus. So is a keyboard, is a smartphone Can you say that a smartphone is a computer? And if yes, why? Why do you say that it's a computer? Why is it a computer? Why do you think it's a computer? So we can say, we can classify our smartphones as a computer, because today we have smartphones. Yes, they accept data and they process it, true. And we have some smartphones that have capabilities. Their capabilities, are higher than some of the old generation computers. So in the case of our smartphones, you can see that some of the components serve two purposes, like the is it the touch screen now? So the touch screen of our mobile phone serves as an input device and also as an output device. So output devices are devices that gives out the results, or they produce information, like your printer. After typing, then you need to print out the hard copy. The hard copy is an output. If you're looking at it from the screen of your laptop or your computer, then you call that output as a soft copy. Soft copy is a result of a processing, but still at that you cannot touch it. But when it's being printed, then you have that output as a hard copy. You can feel it. You print it, you can touch the paper. So that's a hard copy, as opposed to a soft copy. Soft copy is like you're seeing what I'm displaying now, introductory concept. You're seeing it, but you cannot touch it. This is an output of a processing using PowerPoint. But when this is being printed out, then we say that that's a hard copy, and it's also an output. Then we are left with processing. So just remember IPO. In the definition of a computer, there is an input which comes from input devices, like whether it's a scanner, whether it's a keyboard, whether it's a light pen, just name it, whatever, whether it's a camera is also an input device. And then there is a processing. The processing takes place at the central processing unit, known as the CPU. So in the CPU, different types of processing occur there, whether they are arithmetic, which is being done by the arithmetic logic unit, the ALU, whether it's logic, which is done by the logic units. And we also have some registers and buses. But in this course, we are not going to go deep into the registers and the buses of how the informations are being processed, but we just need to be aware that there is the control units, there's a logic unit, and there is an arithmetic logic unit. So everything about processing takes place in the central processing unit, and the results are being displayed in the form of information using output devices, like we made mention of graph plotters, I made mention of the printer. Then you have for sound, maybe your speakers. So the sound goes in through the microphone and is being amplified through the speakers. And you're able to hear what the person is talking loud and clear. So then we also have the storage devices. The storage devices, you can see them even as small as your USB drive. Your USB drive is used to store information. So it's a storage device, which is secondary. Secondary in the sense that you can move it and is movable, as opposed to the hard disk, which resides mainly inside the computer. For you to move the hard disk, then probably there's a fault with it and you want to. So basically, it resides in the computer. But you also have external hard drives, which can be connected to your computer for storage. Storage is you want to put something. Maybe you like a lot of movies, you like watching movies, and you download them from one device and you want to move them to another device. So storage devices allows for those kind of operations. Then we have the software. Software are the programs that run the computer. Let me just, in the layman's language, that the programs that are used to execute tasks in the computer. And the broad classification of software is system software and application software. So you might want to know what's the difference between the both of them. So system software are the things that are native to the system, like, example, the operating system. Operating system, also known as OS for short. An operating system is a software that acts as a go-between it acts as a layer, an interface between the human and the computer itself. An example of a operating system is Windows. Different versions of Windows, whether Windows 11, which is the current one. There was Windows 10, there was Windows 8, Windows 7. Then we also have operating systems for networking like Unix, Linux, Ubuntu. Those ones are open source. So when you say open source means that anybody can change the code, as opposed to Windows. Windows is owned by a company. Nobody can have access to change the code as such. We are going to explain that furthermore. But if it's not clear to you, you can put it in the chat so that I can take some time and explain it well. Then there's the applications software. Application software is they are general purpose applications, general purpose software. Like, look at it this way. If you buy a new laptop or desktop and you don't install an operating system on it, you will not be able to make use of that device. So operating system, they act between the machine and the humans. Why? Because the machine does not understand English, so to say. It understands machine level language. And you might want to ask, what is a machine level language? Machine language is zeros and ones. Probably you've heard of binary digits. So that's a machine language. But for humans, imagine if I want to say, welcome to CSC 227. That's English, I'm saying. It will surprise you that this English is going to be translated to zeros and ones. So find if it's a situation where humans were using zeros and ones to to communicate, then it's not going to be something that we can really enjoy or remember. So if like saying welcome, we'll have to be writing 01000, a kind of representation like that. So, but we have translators that are able to translate these English-like commands to the machine level equivalent, which is not really part of our do I say wahala as such? It's not our own is just to write, but underneath the processing is taking place by translators. But application software, example, let me give you an example of an application software. Example is this software which I'm using for this course, which is PowerPoint, Microsoft Word PowerPoint. So it's an application software. They are software that are being built for a specific purpose. Specific. They have a general on a specific thing which they do well. For the case of PowerPoint, it's best for presentations. Presentation, like I'm delivering a lecture using PowerPoint, that's what it is made for, as opposed to another application which is also an office application, like Microsoft Excel. Microsoft Excel is suited for accounting related processing. So if I want to take like accounting, anything accounting or calculation, a calculation kind of, then it makes sense to use Excel than PowerPoint. You also have different applications, whether for like gaming. I know most of you like to play games. So you agree with me that you can only play games using the game application, specific game application, whether in your mobile phone, whether it's Candy Crush, just name it, whether it's a mobile, combat, fruit slicer, just name it, different games. There are specific games that have been developed. And if I want to play any of such, whether Candy Crush, I cannot go and open MS Word and say I want to play game. It's not going to work. So that is a brief explanation about we've been able to define a computer. Then we divided the computer into hardware and software, and we said the hardware is the physical components, the components that you can touch, you can feel them, and they are further divided into the inputs, the processing, and the output, and also the storage devices, which has to do with memory, to put something somewhere. They use the storage devices like your hardware, which resides in the computer. Then you have auxiliaries or secondary storage devices like your USB, your external hard drive, and other devices as such. Then you also have the software. The software are the programs that make the computer to perform efficiently. And we said they are further classified into the system software, of which your operating system is one of the system software. We have some other ones like your utility programs that help to make the computer to work in the optimum way. One of the utility program is zip programs like WinZip, 7-zip. You have programs like Dix Cleaner, disk defragmenter that just manages the computer and make it to work. But these ones are system related. And for the application software, there are specific applications that do particular things, specialize. Word processing, MS Word. Accounting, Lotus, MS Excel. Database, MS Access. Presentation, MS PowerPoint. Gaming, a particular software for gaming, whether it's Candy Crush on your laptop, on your mobile, whether it's is it FIFA? I think there's one called FIFA for people that like playing game. Yeah. So FIFA on your laptop or your desktop, etc., etc. So I will just look through the charts and we'll continue from there. Is this attendance your G? Okay, I was thinking of questions. So far, do we have any questions? Any questions? Okay, great. So let's see the next one. So the next thing we need to differentiate or know is data and information. When I was defining a computer, I said it accepts input in the form of data and brings out the outputs in the form of information. So what's the difference between data and information? So data can be described as raw facts. They are distinct pieces, distinct, and they're usually formatted in a special way. So when we say distinct or raw facts, imagine that you want to add two numbers, addition, two numbers. So I need to get the first number, then the second number. So assuming now I want to add 10 plus 5, then my distinct pieces are 10 and 5. That's the data. So what happens with data is that you are able to perform different operations on those data, on those raw facts. Like I said, 10 and 5, if they are our data for this example. Then operations that we can perform, like arithmetic operations, whether we are doing addition, whether we are doing subtraction, multiplication. So you find out that the kind of operation that is being performed on those data will determine or give you different, you'll be able to make different decisions out of it, of them. Example, if we want to add those two numbers, so we'll be saying that 10 plus 5 is equal to 15. And by the time we say we want to do multiplication on those two data, you'll find out that multiplication is going to give us 50. And if it was subtraction that we are doing, then we'll be looking at 10 minus 5, which is 5. So you agree with me that the three different operations that were performed on those data, raw facts, we're able to make different decisions from them. So we have 10 plus 5, 15, 10 times 5, 50, and 10 minus 5, which is 5. So we have the facts, raw pieces, distinct. Number one, 10. The second one, 5. and the operations gave us different outputs or outcomes. So information are a collection of facts. Collection. So see information as the outputs of those operations, those different arithmetic operations that were performed on our data 10 and 5. So that's information. We're able to see that the data did not change, but it was just the operations on the data that gave us that output. So information, you can see we have, okay, by the time I added 10 plus 5, I got 15. Same on the 10 and 5, we multiplied, we got 50. Same on 10 and 5, we subtracted and we got 5. So from data, when you talk about data, see it as they are just raw pieces. But information is like you've worked on the data. Something, operation has been carried out on the data. And from the information, you can now make or draw some inference. Inference is from the operations that has happened on the data. So I believe this is clear. Data versus information. So data is raw facts and information is process data. Then we also talk about knowledge. So knowledge is an awareness, an understanding of a set of information and how that information can be made useful. So the whole time in this course, when we talk about processing, information is being processed because probably a manager wants to make informed decision. So there is always like decision making. He wants to make informed decision about the processing that has happened. So knowledge is an awareness, an understanding of a set of information. So, okay, you've gotten those set of information. What is it that you can get from it? So I want to know the performance of students. After a semester, I want to say, okay, for CSC 222, 227, of all the departments that did or took that course, what department, what was the performance like across the departments? So you'll be able to say, okay, statistics students perform 60%, 70% more than the other departments, like a knowledge you want to understand from all these results from the different, what is it that we can make out of it? And knowledge base is just a collection of data, rules, procedures, and relationships that must be followed to achieve a value of the proper outcome. So you look at knowledge base as maybe you want to develop an app for maybe a health related app, or speak to a doctor, consult a doctor. So that kind of app, if that app is going to have a knowledge base, then you can program it such that it uses rules. What do we mean by rules? Rules, procedures. So you want to see if someone presents that they have headache and they have body pains and they are weak. Those are the rules. They have headache, they have a fever, they are weak, they have bitter mouths, bitter taste. Probably, it's likely that they are showing symptoms of what? I'm checking in the chat whether we have some what do you think the outcome is going to be? If someone presents that they have headache, they have fever, they have they're weak. What if you're a doctor, what will you think the person is likely to be suffering from? Yeah, good, good. So yes, so it's likely malaria. So that's a rule. That's it. So well, of all the things that you're suggesting, the most likely should be malaria. So it's likely that. So that's a knowledge base. That means you want to put, it's like you want to put sense. You want to put sense into that app. That's knowledge base. It has a knowledge base. And knowledge base are being guided by rules. So you say, okay, if student is going to graduate with first class, so that student should have A in all the courses. That student should go to library 5 times a week. That student should attend. Those are the rules, kind of thing, something like that. So that's a knowledge base, if that makes sense. Okay. Let's look at the next. So what's the system? Let's see. So system is a set of interrelated components. So you have different components that are related and they are coming together. It's a system. So they have a clearly defined boundary. They're working together to achieve a common set of objectives. And they do that by accepting inputs. They produce an output in an organized and transformation process. So it's system, set of interrelated components that are clearly defined, working together to achieve a common set of objectives. Like university is a system, and relate to university as a system. So for we to define all the 3 basic functions of a system is that first, they must have an input, which involves capturing. There's capturing, assembling of elements that enter the system to be processed. So students, if you take the university as a system, then the inputs are the system, the students or whoever is going to work, whether lecturers, whether non-academics, they're all parts of the system. Processing involves transformation process. It converts the inputs to the outputs. And outputs involves transferring the elements that have been produced by the transformation process to their ultimate destination. So if you say students are the inputs, the processing is the transformation process that happens in the course of study. Processing after first semester, the student sits for an exam, gets a GP. After second semester, they get an accumulative. That same process happens second year, third year, fourth year, fifth year, as the case may be. And the output is that the student gets to their destination. The destination is the class of which they used to graduate with. So that's basic, still the basic component of a computer. Inputs, capture, assembly, processing, transformation, converts, input to output, and the output transfer of elements that has been produced to the ultimate destination. So this model, this is a static. This is a static system. There are no checks to ensure that whether it works properly. But in a system that is, let's say the other case of a system that is dynamic, what happens? So in a dynamic system, all the systems, they have the inputs, the processing, the outputs, but there's something to monitor the performance, some kind of feedback. So there's a feedback and there's a control. Remember I said we can use a student, university, a student as a kind of a system. But I would agree, I would tell you that a student's system is a dynamic system. It's dynamic because there's a kind of feedback. You might ask me what are the feedbacks? At the end of a session, a student gets a cumulative results. And I'm sure you are aware that if a student's GP is below 1, then the student is given a warning, kind of probation. So they tell you that you're on probation. That's kind of a feedback. And a control is required. What control is that? The student is expected to improve such that by the next time the student sits for the exam, the GP should be above 1. That's a control. Above 1. If it's above 1, then the student has left that probation area or the red flag area. So that's a dynamic system. There should be kind of feedback. Am I faring? How am I faring? What is it? Even if it's in a sales, the person is involved in a sale, the person is an entrepreneur and is marketing a product, you should be able to sit and look, okay? In the first month, in the first year I started this business, I was able to make XYZ amount of money. And am I breaking through? Am I breaking even? If I'm not breaking even, what is it that I can do to? So that's the feedback. Or if somebody that is making a product, you can just give people samples to say, okay, please, can I have your feedback about this product? What do you feel? What should I do more? What should I not do more? That's feedback. So feedback is just data about the performance. Like I already tried to explain. What is it that we are doing? What can we improve on? That's feedback. Control involves monitoring and evaluating to determine whether the system is moving towards, for a student, the achievement of its goal is being of good standing. So whereby a student is not of good standing, that's below 1.0 cumulative, then there is need to see what can be done so as to be of good standing. So we have system components. So the system should have a boundary, then types, whether it's a simple system, some systems are complex, some systems are open, some systems are closed. So when it's open, when you say system is open, that means it can receive inputs from the environment. And sometimes it's able to return the output to the environment, as opposed to a closed system, which neither receives inputs or produce outputs. So at this point, anytime I take this class, I used to tell the students to, by themselves, let them look out for, or they should be able to identify. So it's like an assignment. Assignment number 1. types of system. What's a simple system? What's a closed system? What's an open system? What's a complex system? You should be able to understand those concepts with examples. So we also have operation support systems. These are different types of systems. If it's not making any sense to you, don't worry. As in the course of the course is going to be much more clearer. So this operation systems are just talking about processes. It processes a business transaction. Remember, the course is information to computer processing. So you'll be hearing a lot of process, business related, decision making, knowledge, and all that. So operations. So if they say somebody is working in an operations department, operation support, if it's just about business transactions, controls in industrial processes, support communications and collaboration. Then it updates the database, corporate database. So we used to use Access. Access is a database application that we use to process information. So we use it for this CSC 227 MS Access. Like I made mention of decision making. So every manager, anytime you're doing any processing, should be able to, or what is it that I want to make out of this? So the stages in decision making include, there's a problem definition, there's a design, there's a choice, and there's an implementation. So they have to be a problem first. Simple problem that I gave, adding two numbers. Maybe I just want to, you can define the problem as arithmetic operations on numbers. Then the design can be what type of information am I going to add? Choice. Am I going to use software to do it? Or am I going to use hand? Is it something that I can just use paper and pen? Implementation is how do I want to do it? How do you intend to do it? That's implementation. So if I want to process, exam scores for students, that's my problem definition. So my design is, how am I going to, okay, which students am I doing the processing for? Is it for all the students that took a particular course, example CSC 227, which sometimes the students are about 1,000 plus. Am I going to be the only person that will do that processing? Am I going to share it with a colleague? How are we going to go about it? Is it that we are going to mark all the scripts by hand? Or is there a machine that will be used in carrying out? You can see we are arriving at the decision, which is processing the results. So we have to, first of all, follow these steps. Define the problem, design, choice, how you're going to do it, and implement, carry it out. So you can use that same thing for different, anytime you want to make decision. So the types of operation support, there's a transaction processing. Transaction is about like sales processing, inventory, accounting, transaction, bank, like it's related to accounts. Then there's a process control. Like in the refinery, the use of sensors to monitor chemical processes. Then there's the enterprise collaboration, like what we are using, Zoom. Zoom is a collaboration system. So we are using it to allow us to do like teamwork or group work, whether it's video conferencing, whether it's messaging or email. That's it for. And in decision, there are different types of decision. There is a structured decision and unstructured decision. So when you see something is structured, a structured decision is a repetitive routine. So you keep doing it. Involves a finite, definite procedure for handling them. And for unstructured, the decision maker must provide judgment and evaluation. So in that problem definition stage, the decision makers usually are like top. If in the case of organizations, they are top like CEOs, that are the people that are top organs, decision maker. In the case of the university, vice chancellor, the people in the Senate. But this day, you agree with me that everybody is like a decision maker, because you living in Nigeria, everybody makes one decision or the other. How to get to school, what to eat, you're always thinking at the top because you want the best. The resources are limited, but you want the best from yourself. So you're always thinking out, looking out for better ways of arriving at something. Even if you want to buy data, you're looking out for the data that is a cheaper, so to say, and is also reliable, kind of. And there's also a semi-structured. So the only part of the problem has to be clear. Only part of it has to be clear-cut answer provided by an acceptable procedure. So that's for semi-structured. But in the course of the course, we are going to look at all this. This is just an overview of what we are going to be looking at. So there's batch processing. When we talk about processes, there's batch. Batch processing is look at kind of operations that happens only periodically. What I mean is that, let's use an example like students exam processing. Students exam processing happens only after the semester exam. So that's a kind of batch processing. Another one is like banks or salary. People that earn salary, they are being paid only maybe at the end of the month, or for some maybe 2 weeks, some weekly. So the thing is, the transaction happens after a period of time. That's for batch. And they like have a whole group of people, group of staff in one department. All of their salary are processed at the same time at the end of the month. That's batch processing. Or check. If it's bank check, they get all the checks maybe at the end of the day and they send it for clearing. That kind of thing. It's not as if you just go, you give them your check, they carry your check. They just group everything, all the check received, and they process it. That's batch. Then you have online. In the case of online, it's a transaction, a kind of a transaction that happens immediately. Immediate. So like you want to withdraw money from the bank ATM. So that's an online processing. Or you want to reserve book flights, airline reservations online. These days, we also have ride. You can book a ride, whether Uber, whether Bolt, whether InDriver, just name it. So that transaction process that happens immediately, that's an online process or processing. So this is just talking about the levels of decision making, operational management, then the strategic. Then this is about information. IS is information system. So we have classification of information system by scope. So we have the functional business systems. This one is talking about focuses on the operational and the managerial applications of basic business functions, whether it's the support accountants, the marketing, or the finance. And for strategic, it's about helps to get a strategic advantage over. So if you're strategic, so you're looking out for how to get an advantage over some other person. In this case, it's over customer. So you're looking at how best to be the best fintech, whether it's an e-commerce web system, whether it's a shipping tracking, online sales, that's e-commerce, whether you're the Jumias or the Kongas, that's strategic information system. Then we have the cross-functional informational system. So these systems are combinations of several types of information systems, and they provide support for many functions, cross-functional. Then information system is just a combination of, so when you say information system, you're looking at a combination of the work practices, the information, the people, and the information technologies that are organized to accomplish the goals in an organization. So each organization has their own work practices, and they have the people that work for them and the technologies that they use. So yesterday I met somebody that said he wants to send a document to me, a word processing document. And he said in their office that nobody is using Microsoft Office anymore. So if they want to do word processing, they do it online using Google Docs. And I was like, why? He said because you cannot buy Microsoft anymore. Or even if you buy it, you need to be paying, like paying for the license. Because most Nigerians are used to buying counterfeit software without, you know better than I do, without paying for it. So as a work practice, so everybody now is using Google Docs online. Everything is online. And I said, oh, so if you don't have an internet, that means you'll not be able to type. And he said, yes, because everything is web enabled. It's on the cloud. Google Docs. Google Doc is like it's similar to Microsoft Word. So no, not Microsoft Word now. It's similar to Microsoft Office. If you know Office, MS Office, where you have Microsoft Word, Microsoft Excel, Microsoft Access, PowerPoint. That's Microsoft Word. Google Documents is like a suit. It's suit whereby it has all those Word, Excel, PowerPoint options. But the difference between the both of them, between Google Docs and Microsoft Office, is that you can only use Google Docs if you're connected to the internet. So if you're not connected to the internet, you will not be able to use it. So this explanation came up because I was trying to explain work practice. Somebody is telling me that in their office, everybody is using Google Docs. No more Microsoft Office. So that's a work practice in his organization. Then for some people, you will not be able to probably use Facebook when you are in the office. Maybe they will do like have a firewall kind of. You'll not be able to access those things so that you can concentrate and give your best to the work which you're doing. So work practices, information, people, and the technologies. So this technologies like Google Docs, part of them, and they do that, they organize to accomplish goals in an organization. So the components of an information system, they include the people. So you have the people resources, different cadres of people. They're the end users, can be the end users, the people who use the information system or the information from the information system. The information system specialists, that's the people resources, that are the people who develop and operate the information system. Then you have the hardware resources, which include all the physical devices used in information processing, whether they're the machines, the data media, the peripherals, the hardware. That component is the hardware. And you have the software resources. That's the information processing, instructions, that's the programs and the procedures, the software, system software, the application software, and the procedures. You also have the data resources. This has to do with the facts about the business transactions, the process, organized information, the database of the organized data. That's the kind of database they use, whether it's in the cloud or whether it's offline. Then you have the network resources. That's the communications media, the network infrastructure, whether it's hard, that which includes the hardware, the software, the internet, the intranet, the extranet. We are going to learn all those ones. Also know what's an intranet, what's an extranet. Then if you want to measure the success of an information system, you'll be looking out for things like the efficiency. When you see something is efficient, you want to look at, does it really minimize costs? Like I was saying that today in Nigeria, everybody is like a decision maker, always looking out for the best ways to get things, minimize costs, which one is more efficient. I want to buy data. Which one is cheap? Maybe not only cheap. Can I get one that is not going to be lapping? The lap would not be too much. So minimize cost, time, and also use of information resources. Then effectiveness. You're looking at, does it support business strategies? Does it enable business processes? Does it enhance the organization structure and the culture of the organization? Then, of course, how do we increase our customer and business value? So I asked this question, you should be able to know what's the difference between efficiency and effectiveness. Two questions now, efficiency and effectiveness. And this is our NIS solutions. So if you're to develop an information system solution, you start by investigating what's the problem, like problem definition, investigation. Then you analyze it. Then you go, you design. Let me Really nice. Let me carry this one. So you investigate problem definition, you analyze it like you do the feasibility study, then you design the system. It means like an architect puts paper and pen and have like a template, a blueprint. If it's code, you look at the components of how to write the code. Then you implement, write it, write the code, and you maintain. So at this point, if it's to deliver a system, you implement and you deliver and you maintain. Maintain is from time to time you check. Are they errors? Is it really performing as expected? If it's not performing as expected, then you go back to the problem. You investigate it. Why is it not working? You analyze. So it's a continuous cycle. So I'm going to stop at this point and take your questions. Let me look in the chat if you have some questions. You can also raise your hand and I will ask you to unmute yourself so that I can take your questions. So if you have questions, you can put them in the chat or you indicate by. Are we going to code? No, there is no coding in this course. It's not a programming course as such. The software that is used is Microsoft Access. Access is not like coding Python. No, it's not. Okay. There is the material for the course, right? So in due course, I'm going to tell you how to get the material. So like I said, you can ask your questions. And what I was able to do today is just give us an overview of what we are going to be doing. I told you that there is a course material. So in due course, I'm going to tell you how to get that course material. I always encourage the students to read the material, course material, not the slides. The slides are just snippets. They're just snippets from. Okay, so before we go, let me use this time to know the departments. Please kindly indicate the departments that are offering the course. And I asked also at the beginning of the course whether all the class reps are in the WhatsApp group created for the class reps and the course lecturers. If there's any class rep that is not in that group, please let me know. And I will take down let me know so that you can be added to the group. I said in due course. So I don't have information with regards to the course material now. And I told you that in due course. So what it means is that when I have that knowledge, I will share it with you. So we have chemistry, science. Okay, this is the department. Just a minute. Do we have anybody from law here? Law. No law. So maths education, mathematics, statistics, chemistry, microbiology. Nobody from management science. Is there anybody from management science here? IR, IRPM. Is there anybody from finance? Anybody from finance department, IRPM, law? So all these class reps are in the WhatsApp group. Mathematics education. I thought I saw something as chemistry education. Did I? Math education. Yes, of course. The course is interesting. It's an interesting course. Wow, none at the moment. Okay. So I guess all of that's the 6 of you are in the WhatsApp group. Okay, chemistry science only. Chemistry science. Okay. Okay. So all this iPhone, you name your when you attend class like this, you name your device. You attach or rename your device to bear your name. Not iPhone 1, not Techno CKC. So if they are taking the attendance, who is Techno CK6? You write your name, full name, so that your attendance can be stored. If you check my name, you see my name fully spelled, not Peter or not Xiaomi. So I would take it that you don't have any questions, that whatever I said today was understood. Is that the case? Is that correct? Okay. Okay, great. So if that's the case, I'll just be around for what's the time? Wow, so okay. Spend some time. So if you don't have any questions, then I'll just be around for like 5 minutes and I'll end the call. So have a nice weekend. Industrial chemistry. Industrial chemistry and chemistry, they're not the same, are they? Chemistry science. Are they the same departments? Please, I need to know, is it the same? Yes, okay. You're still together. Okay, it's fine. So you have the same. So how is it like you have the same one department, but different options? Is it something like that? Okay, great. Okay, it's fine. All right. Okay. Like I said, I'll just hang around for a few minutes and I'll end the call. Okay. So till next week. Have yourself a nice weekend. Bye.